Hey guys, Mr. Maz here, coming from my backyard this morning. A little cold and chilly out, but it's okay. Today's lesson is on the Pythagorean Theorem, and I wanted to show you kind of a real-world application of it. So in my backyard, we are about to put an addition on for a new bathroom because I have 3 girls in the house, and when they get ready in the morning, one bathroom just isn't doing it. Construction was supposed to start 2 weeks ago, but the coronavirus kind of put a halt to that. So this is where the bathroom is going to go. You kind of see the white lines on the ground for the layout of it. And you might be wondering where the Pythagorean theorem comes into play. And unfortunately, you can't just rely on someone spray painting lines on the ground to make sure that it's perfect square. The Pythagorean theorem actually comes into play here. And once we go over the Pythagorean theorem, I'm going to show you at the end of the video how to make sure that we can build things squarely. We've talked about the Pythagorean theorem before, so let's start with a quick review. First, this theorem works only for right triangles, which are identified by the 90-degree or right angle, often shown in the little corner. So this guy right here. Also, it's important to remember the parts of all right triangles. When you identify that right angle, the two sides that make the right angle, these are called the legs. The other side is called the hypotenuse. Remember that the hypotenuse is always the longer side. This is especially important to remember when you just have numbers given as side lengths and not an actual figure. Now the theorem itself states that a squared plus b squared equals c squared. What's important to remember is that a and b are the legs. And it doesn't matter which order you have them in. You can have the leg on the left be a and the other one be b, or you can switch them around, have the bottom leg be A and the other one be B. That makes no difference. But what is very, very important to remember is that the hypotenuse is always C. One of the main reasons for having the Pythagorean theorem is to find missing sides of a right triangle. So when we look at this particular right triangle, we see the right angle is right here. And therefore the two sides that make the right angle are the legs, which means this rectangle or this triangle is missing the hypotenuse. So once again, it's a right triangle, so we can use the Pythagorean theorem. And I'm looking at the Pythagorean theorem. A and B are the legs, and once again, order doesn't matter. 11 can be A or 3 can be A. I'm going to go with 11. So 11 squared plus 3 squared, that represents the legs, equals C squared. C is the hypotenuse, it's the unknown side. So now we just do the math in front of us. 11 squared is 121. 3 squared is 9. We further simplify that, adding them together to get 130 equals c squared. But the point of algebra is to isolate that variable to get c by itself. C is not by itself right now. It has a square. So a lot of people forget the inverse operation of that square. The way that we undo squaring is to take the square root. So we take the square root of both sides, so c ends up being the square root of 130. 130 is not a perfect square, so it's an irrational number. So if we wanted to estimate that, say to the nearest tenth, that ends up being about 11.4. So for this particular triangle missing the hypotenuse is 11.4. And remember, the hypotenuse is always the longest side, and that checks out. 11.4 is bigger than both 11 and 3. For this particular example, we once again identify the right angle. So the two sides that make the right angle are the legs, and this time we notice we are missing a leg. All right, we have the hypotenuse here, 10, but we're missing one of the legs. So when we look at our a squared plus b squared equals c squared, we are going to have one of the legs, and it doesn't matter a or b, represent the variable that we're going to try to find. So I'm going to use a as the variable we're trying to find. So this is the unknown down here. So I'll have a squared plus 8 squared equals 10 squared, which is representing our hypotenuse. So if you go over and look at the triangle, 8 ends up being b, and c is our 10. So going through this, we simplify the squares. 8 squared is 64. and 10 squared is 100. Now in order to solve for a in this situation, we need to undo our plus 64. So we are going to subtract 64 from both sides of the equation. That's going to leave us with a squared equals 36. And once again, like the last problem, in order to undo the square, we need to take the square root of both sides. And this time 36 is a perfect square, so we get a nice whole number answer here. A is 6. So our missing leg is 6. And once again, just a reminder, the hypotenuse is always along the side, which is 10. 10 is larger than 8 and 6. Next up, we have a word problem here. We're going to try to have a little bit of fun with this one. The first thing it says is Caleb is flying a kite. So I'm going to find a kite here that we can use. And we have to keep in mind that this drawing is not going to be to scale. So Caleb was flying a kite and decided to tie that kite to a rock on the ground. I don't know, maybe he got sick and tired of holding it. That's a big rock. Let's make it a little bit smaller. There we go. So Caleb has got this this rock that he's tying a string to. There's our string. So something kind of like that. And then he stood directly underneath the kite. All right, so I kind of skipped over part. I said he knew that he let out 50 feet of string here. So we got to keep that in mind. The string is 50 feet long. He stood directly underneath it. Let's see if we can't get Caleb under here. This looks like a more anatomically correct person. So he is directly underneath the kite here. All right. So we've got all this going on. So reading through the problem again, it says that Caleb was flying a kite, decided to tie the string to a rock on the ground. He knew that he let 50 feet of string out, and then he stood directly under the kite, and he was 20 feet away from the rock. And the question is, how high was the kite? So let's put some information on here that we know. So we know that the string was 50 feet. We know that Caleb is 20 feet away from the rock. And what you should kind of see here is we have a right triangle. If he's directly underneath the kite, that means we're going perpendicular up. We're forming a 90-degree angle. And this, now I see, this is why he decided to tie the string to a rock on the ground, is so we have a right triangle here. So, as always with the Pythagorean Theorem, we are looking at identifying where that right angle is. So, here's our right angle, meaning that this 20 is a leg, and this unknown length here, which is how high the kite is, which is what the question is asking for, is another leg. So this is a Pythagorean Theorem problem where we are missing the leg. So when we're looking at a squared plus b squared equals c squared, we're missing an a squared here. So that's going to be the variable that we're going to try to solve for. 20 is our other leg, and naturally 50, the side opposite of the right angle, is our hypotenuse. So 20 squared is 400. 2 times 2 is 4. We have 2 zeros there. 5 times 5 is 25. Add the 2 zeros. So 50 squared is 2,500. And since we're missing a leg, we need to subtract 400 from both sides to start isolating a. So a squared is 2,100. And then we are going to take the square root of both sides to get a by itself. And 2,100 is not a perfect square, so we're going to end up with an irrational number, an estimate. And it turns out that a is about 45.8 feet. So Caleb was actually doing all this to figure out how high his kite is actually getting off of the ground. And it turns out that that kite is about 45.8 feet high. So now we're going to look at the bathroom problem. Like I mentioned earlier in the video, we're going to try to put a bathroom on the back of our house, and our hopes are to make it a 12 foot by 12 foot bathroom whenever the contractors are allowed to get back to work. Now what you'll notice here is I have a figure representing that bathroom, and every side is 12 feet, and I can move it however I want. Those sides stay 12 feet, and a lot of people are under the impression that just because all the sides are the same, they think you get a square, but that's not the case. In actuality, you really get a rhombus. And the angles, as you can see, they can go anywhere from 0 to 180 degrees. So just because all the sides are the same doesn't ensure you have a right angle. So how do we use the Pythagorean theorem to make sure we have a right angle? Because I don't even see triangles yet here. But what I can do is I can go ahead and put a diagonal across this rhombus, and now you see we have triangles. And the Pythagorean theorem says if you have a right triangle, then a squared plus b squared equals c squared. There's something called the converse, which switches the order of that, saying that if you can get a squared plus b squared to equal c squared, then you have a right triangle. And if you have a right triangle, then that angle is going to be 90 degrees. So when we look at this, we are going to use a squared plus b squared equals c squared. And remember, when using the Pythagorean theorem, we want to identify the right angle. Well, in this case, we don't have the right angle yet, but this is the angle that we want to be the right angle. So that means the 12 and the 12, these are going to represent the legs that we want to use. So we're going to look at taking 12 squared, and I apologize, this is a little bit more difficult to write in than the other software. So 12 squared plus 12 squared is going to equal c squared, and that's our diagonal there that's labeled L right now. So 12 squared is 144. We have two of those. And 144 plus 144 is 288. And as we've talked about before, in order to isolate c to get c by itself, we need to take the square root of that. That's very important. Don't forget the square root in order to undo the squaring of c. So 288 is not a perfect square. It's going to be an irrational number. So c is going to be about equal to 16.9705, and because it's irrational, it's going to go on forever and ever and ever without repeating. But 16.9705 feet. All right, so that's what we want to get our diagonal to be. All right, so let's go ahead and try to do that real quick. I'm going to try to get the measure of this object here. By showing the value. So right now the value is 17.16, which does not make a 90-degree angle, as you can see. But if we move these around and see if we can get it close to 16.97, I just had it and lost it, 16.97. Now you see it's not exactly 90 degrees, but it's pretty darn close. So remember, we're not exactly at 16.97. It's 16.9705 and a little bit more, so it's not going to be exactly 90 degrees. However, if you look at a tape measure, you usually need to go to 1/8 of an inch in the construction world, and this turns out to be about 16 feet, 11 inches, and 5/8 of an inch. So in review, there are two types of problems that you're going to get with the Pythagorean theorem when you're trying to find missing sides. The easiest one is probably when you are missing the hypotenuse. So you identify the legs by finding the right angle. So here the legs are 12 and 5, and you substitute them into a squared plus b squared equals c squared. In this case, you add them together, and then you take the square root to find the hypotenuse. The other is you identify the right angle, and you see the legs here. We're missing a leg. And when you're missing a leg, substituting the information in the Pythagorean theorem, you're going to end up subtracting these squares from each other before you take the square root and find that missing leg to be 21. Now there is an assignment in ALEKS for the Pythagorean theorem for you to complete, and then later on in the week we'll look a little bit more in depth at the Pythagorean theorem and how to apply it repeatedly for some study island problems.